So if you take the table of values here and we add 3 every term, my graph for that one is moved up 3 units. Every y coordinate gets 3 times bigger because we do the function. So we square the -3 first and then add 3 to it. With this one here, we square the -3 and then we subtract 3 to it. So that drops the graph down. Now we call this a vertical translation. Okay, it's not a transfer. Well, it is a transformation, but a translation is is a subcategory of transformation. What do you think will happen? Now, here's a different thing. Notice this is different. What's the function in this case? The function is the absolute value of x. So I'm going to subtract 2 from x and then plug it into my absolute value. So I want you to make an educated guess on what's going to happen with the graph here. And I would like you then to plot that on, do the table of values here. Now remember, you are subtracting 2, I think. Yeah, you're subtracting 2 from the function and then plugging it into the absolute value function. So I've done my table of values a little bit differently because we're going to take the value of x, subtract 2 from it, and then plug that into the absolute value. So we have 6, 5, 4, 3, 2, 1, 0, 1, 2. When we plot this on the graph, we have a graph that looks like that. Because we have to be, so here's what you think about. To get the same value, 0, for this one, if I subtract 2 from that number, I have to be 2 bigger to get that value out of my function. And if I do the same thing for this and I add 2 and then plug that into my function, which is that absolute value, -2, -1, 0, 1, 2, 3, 4, 5, and 6. What happens here, they don't have to be as big because I'm taking my x value, adding 2, and then plugging it into my rule or plugging it into my machine. So I don't need to have as big a number. So my 0 becomes negative, or my vertex in this case becomes -2, because -2 plus 0 plus 2 gives me my 0. Plug that in, that rule gives me 0. So now I have a graph like this. Okay. So what we have here is this idea, and we talked about it, or Mrs. Lau, we talked about it last year, where we are going in a different direction. If it's x plus 4, well, it's not really x plus 4. We think about it as x minus -2. So this here is the opposite direction that a lot of us want to put it. But it is because we are adding 4 to the value of x and then plugging it through the rule. So I'm 4 bigger than I was to begin with when it goes through my rule. So I don't need to have as many or as large an x value to get the same y value out, because you've added in this case. If I've subtracted, I got to keep writing on that smartboard. If I subtract this, now I need a larger x value to get the same number going into my machine for its input. So what does if we take the equation y is equal to f of x minus h plus k. Now, the only difference from what you had last year, this is the only equation that you talked about, okay? The vertex form of the parabola. So what does h do? Well, h moves it right or left. If it's a positive h, which was going to give you x minus h in the brackets, this moves it to the right, because we need a larger value of x to then plug into the rule to get the same output value. If it's a negative x, or sorry, negative h, I should say, this is going to give you x minus negative h, which we almost never put down. We write this as x plus h. And this moves it to the left. K moves it up or down. Okay, and in this case, it actually does make sense, because where we have our K on this side, okay, we haven't really done anything different. It's still a positive K, moves it up, and a negative K moves it down. Okay. Now, we get a little bit confused sometimes. This part, we get this almost all automatically. This part here confuses us a little bit. But we are not talking about two different processes. We're just talking about a slightly different way of writing the equation. I can write this equation here in this form. Okay. All I do is subtract k from both sides. Or I start with y minus k is equal to f of x minus h and add k to both sides. They're not really two different rules. If it's in this form, and I see y plus 2, well, I know that moves it down, because that's y minus -2. I have a negative k value. The only thing is, when I move it to this side of the equation, the negative shows up automatically. So we have some issues with that. Okay, so keep this in mind. These aren't two different rules. I just usually write it in this form, but this form is one that is useful for us also. defined, this is sort of a defined implicitly function, much like when we talk about a general form of a linear function. So what happens when I replace y with y minus 3? If I start with this equation, y is equal to f of x, and I replace y with y minus 3, what happens to the graph of that function, f of x? Is it going to go up, down, or left, right? It's going to go up or down, because I've talked about, I've changed, I've done something to the y value. That's the output value. That's always your up or down, whether I'm moving it or I'm stretching it or I'm reflecting it. This is, we more commonly, we can write this as y of x, f of x plus 3, and as Kyle says, it moves up 3. At least Kyle indicated with his thumb. Okay. Nobody wants to talk to me. I have to read sign language now. X is replaced with x plus 4. So I'm going to take my x, I'm going to plug in my x plus 4. Sean, is this a left-right move or up-down move? It's a left-right because we've manipulated the x value. The x value, the input value, is always a horizontal something. Stretch, move, reflection. Which way am I moving this? Am I moving this? Did I take the graph and I move it 4 units to the left? Or did I take the graph and move it 4 units to the right? If we write it in the form that we start with up here, which is f of x minus h, so I take my graph and I write it f of x minus negative 4, that's not a bad way to indicate, okay, I know that's going to move to the left. The other way of thinking about it, I need four, I can be 4 units smaller because I added 4 to this to get the same output value. So this is a move 4 units left. And now combining these, y is replaced with y plus 2, and x is replaced with x minus 3. Might be easier in this case to subtract 2 from both sides, just because it gets back to that form that we initially talked about, that form that's very similar to what we used for vertex form last year. And we have a move 2 down. That negative 2 tells me here, think about this as y minus negative 2. That'll also give you your 2 down. Here we have, I can't even write here. This should be x minus 3 because so x minus 3. That's going to be 3 units. And this is going to be towards the right. Because I don't need this, I can have a smaller, or sorry, I need a larger value of x to get the same output value out of it. X minus a positive 3. Okay. Now, I call this function notation. I'm sure it's called function notation for other parts, where the function is part of it. Can we please put the phone away? Where the function is here. The mapping notation is another form of this, but this is it's kind of opposite what we were saying there. This is what is happening to the value of x. Okay, so here we have f of x, and we have the mapping notation x comma y. So some point x, some point y becomes the value of x plus 3 and the value of y minus 2. Okay. The reason why this describes 3 units to the right is because I've taken the table of values, whatever it is, 3, 0, negative 3, okay, and this table of values become 3 plus 3, 6, 0 plus 3, and, okay. So here we're actually manipulating the x coordinates. When I give you mapping notation like this, I'm manipulating the coordinates. I'm not talking about what they do when they get into the function. I'm talking about what happened to the coordinates on a table of values. So this is a 3 to the right, and it is going to be, if I had 4, 2, and 0, because I'm lazy, I'm going to end up with 2, 0, and negative 2, because I'm subtracting 2 from each of the y coordinates. Now, this is going to be different than what we see on our function notation. What we have here, we have to first say, okay, this is a 3 right and 2 down, because that's what they're telling us to do. On our function notation, to get 3 to the right, I need to subtract 3 from this. Then plug it into my function and then move 2 down. Over here, or y plus 2, so add 2 to both sides of this, and this would be the other notation. So you have to go from mapping notation to the transformation in words, and then you can plug it into the function notation. Or same thing with function notation. I take the function notation, okay, what happened to the graph in words, and then what happened on our table of values for our mapping notation. Okay. So what do we have here? We have xy becoming x minus 2, y plus 3. So this means every value of x is 2 less. Okay, because I'm taking the values and then I'm creating another equation with these x coordinates, or another function with those x coordinates. So I move this 2 units left because every one of my x coordinates is 2 smaller than it was. And my y plus 3, here are my y coordinates of my hypothetical original function. I'm going to add 3 to both of those, 7, 11, and 19. What did we do? We took that graph and we moved it up. So we have 3 units up. Now, once we have that understanding, okay, this is what we did to our graph. Now we have to say, okay, what do I do to the equation of my graph to get those things to happen? This is fairly simple. I moved it up 3. I'm going to add 3 to my function afterwards. In the middle here, I moved it 2 units left. Well, how do I get a function to move 2 units left? X minus negative 2. So we always write this in that form, x plus 2, whatever the function is. Some strange function that's my original original table of values for my function. My new function after this mapping notation, every x coordinate gets 4 added to it. 10, 9, 8. Every y coordinate has 12 subtracted from it. -2, +2, and -5. What did I do to those functions by turning them in? Which way did I move it? Horizontally. 4 units to the right. These guys are bigger. So my notation, 4 units. This is the actual transformation. I picked up my graph and I moved it this direction. I picked up my graph and I moved it down 12 units. So to get a 4 units to the right, okay, my function needs to be, my x value can be 4 larger than it was before. So I'm going to take my x minus 4. Okay, so notice how that sign in mapping notation is different than in function notation. And I'm going to subtract 12. I know you need to get comfortable with having that notation too. Okay, so basically it's just in this case, added 12 to both sides to get that notation. Notice in this notation, with the y plus something, everything is the opposite in terms of the mapping notation. Mapping notation, what do we do to the coordinate system, the coordinate points? Function notation, what do I have to do to the function to get that to happen? Oh, why did I make her write that? Okay, so your whiteboard work is in your textbook, page 12, 1, 3, 5, 6, and 7. That is due Thursday. So you have the option for the next 36 minutes or whatever it is to either do this homework along with this homework here, which is written below, or study for your exam tomorrow. Okay, that could be going over your quiz or whatever. It's up to you guys, but I want you to use this time effectively somehow.